think so. All right, hi everybody. Thank you for joining me today after the keynotes, where we're going to talk about cloud jumping with Kubernetes. So about me, I'm James. I'm a technical lead at a company called Manifold. We make a marketplace for developer-focused SaaS products. Sorry, you can't hear me? No? Audio is not so, oh, now it's really loud up here. Cool. Yeah, so we make a SaaS marketplace for developer-focused products. Awesome. And if you ask my coworkers about me, they might say that I like to overuse makefiles and underuse shell scripts. Is that accurate? Accurate, all right. And there's some links where you can find some more info about me. So what we'll go over today is just cover a quick story about our infrastructure at Manifold, and then sort of why you might want to cloud jump or move between providers and why we are. And then some ways that Kubernetes is helping and maybe hurting us. And I'll give some sort of pertinent tips along the way. And since we're like first thing here today at KubeCon, I'm going to point out some other talks that I think might be useful, sort of in similar subject matter. All right, so growing our infrastructure. So just want to start out with a caveat here. This might be your infrastructure, right? Lots of containers, real big. This is ours. So we have a relatively small infrastructure, right? We've got tens of container images and some secondary ones with that. And we run about 70 pods right now per environment, a number of logical databases, and sort of tens of nodes per system. But I feel that the lessons that you can take from migration can apply to any size infrastructure. It's not so much about the size, but about the variety of the workloads that you're dealing with. We have sort of a standard layout sort of for our microservice-based architecture, where we've got one Ingress, and then that connects with a number of apps, and each one, most of them sort of is paired with a background worker, and then they all have their own database. And then there are some sort of secondary workloads beside that. And I just wanted to point out that I do accept wayward and orphaned little foam containers to add to our container infrastructure. So why would you cloud jump? For us, as we were running our infrastructure, we moved to Kubernetes about a year ago now. And we started to think like, okay, well, is it about money, right? That's sort of one of the big reasons is we built our system on top of the cloud provider. We run our own control plane. So we run our own host nodes, right? And if we move to managed Kubernetes, we could save some money by not having to run the control plane. So, cut down on 3 hosts. Or is it about saving time, right? So we actually spend a lot of time managing the control plane and managing the nodes, right? So were we moving to Kubernetes for some purpose, or were we doing it just to move to Kubernetes? And the purpose sort of has always been to make everyone's lives easier. And by managing our own control plane and managing our own nodes, we added sort of an extra layer of abstraction that we then had to care about. So instead of dealing with apps and infrastructure, we were dealing with infrastructure and then a sort of the Kubernetes layer and then our apps. Or is it about dependability and reliability? In running our own system, as we sort of took on more load, we started to experience some stress around the edges, particularly like at the networking layer. It's like, we've configured this, but do we really care about it? Not so much, because we're just worried about our applications. But I'd say the main thing for us was just about time. right? Like, we didn't want to spend all this time managing our own control plane. We like the features that Kubernetes gives us, but we don't want to be in the business of managing Kubernetes ourselves. So we did a little comparison, right? And we are on AWS on a sort of, self-built system. And the biggest thing that sort of stands out for us with GCP was having much more like managed everything, right? And Azure has sort of similar things where you don't have to care so much about the nodes, which is good, right? First talk I wanted to point out is this one, which looks really great. And so we can all sort of take a lesson about, maybe we're focusing on the wrong thing if we want to deliver applications and we're spending all of our time delivering a cluster. That might be the wrong focus. So the first tip is that cloud jumping isn't or doesn't have to be multi or hybrid cloud. We're not looking at having a long-running multi-cluster setup here. So that means that we'll be making, and have made different choices about what exactly we're going to do, right? If you're doing a migration, then maybe you're okay with doing round-robin DNS for like a day or two. But for a longer-lived setup, maybe you actually have multiple clusters because you want to serve closer to the geographic regions of your customers. So round-robin isn't going to make sense for you anyways. And so this isn't actually a success story, which is a fun thing to say up on stage in front of everyone. It's still under construction, and that is because migrating between cloud providers is hard. We started many months ago, and we're still going, because other things come up. And maintaining the existing cluster was taking away from the resources that would be doing the migration. But we're going to talk a bit about how Kubernetes can help with this, and it does still help. And it does make it better than starting from scratch. So big tip here, and sort of a humbling thing, is to get help, right? Consider professional services. There's lots of people that spend all of their time moving code from one service to another so they can take care of some of the work that is a bit more tedious. So that's what we're doing, and I can give some recommendations for professional services if you're interested. So defining your infrastructure. Our infrastructure before Kubernetes, a little over a year ago, was this beautiful, giant blob of Terraform. It was glorious, right? You could run Terraform apply, and it would bring everything up from scratch, and you'd go from having no system to all of your code running, the latest sort of deployment version. And then as we moved to Kubernetes, we maintained that existing Terraform, and then sort of defined our VPC. And then we brought in kops to set up our cluster itself and to deploy Kubernetes. And then on top of that, we have all of our YAML. So this sort of layout happened a bit by accident and a bit by the tools that were involved. But it works out really well. So, if you're going to be doing or think that you may need to move between providers, and I think it just works out well for deploying code as well, sort of leverage the fact that maybe this new YAML that you're using to deploy your applications isn't the Terraform you had before, and just assume that the two pieces are separate. The other tip is to, you don't have to use templates specifically, but use templates from the start. So as we defined our different environments, we sort of follow the examples and make a bunch of YAML. Then you end up with several directories of duplicated definitions. And it would have been much better if we had brought in some extra tool to sort of help deduplicate that across environments. So yeah, another talk here, customize is what we're looking at to deduplicate across environments, and this might be a good talk to attend on that. So the parts that you get for free to help you with your migration is the Kubernetes API, and it can't really be understated that the fact that there is a way that is supported by the major cloud providers to do deployments of your code, and it's common across all of them. So we have our deployments and the stateful sets and jobs as well, right? These are ways to deploy a variety of different workloads that are supported in like the major cloud providers, and it's hard to sort of pin down a point where it's been like that before. So next tip here is to take advantage of jobs for things like schema and data migrations. And why this matters is, as you're going between providers, even though you're speaking Kubernetes, there's still going to be some differences in how you need to connect to your data stores or how you sort of authenticate into your VPC. So if you just assume that everything's going to be running in your cluster, then the connection setup will be the same sort of for your code as it would be for your migrations or any sort of one-off jobs. So another tip is to put your trust in Kubernetes. Again, sort of part of the common API here is like network policy for defining your boundaries between services. As we were defining our cluster, it felt very scary for me to not have something at a lower level, but it's worked out fine, and this is a primitive that we can port between cloud providers. So buy into the ecosystem, right? There's all these other parts that are sort of central and then sort of secondary to Kubernetes that can help you with your migration. So ingresses, of course, are a very sort of centralized part here that will help, but like relying on cert manager and external DNS, so you handle your SSL or your TLS automatically with cert manager, and use external DNS to sort of automatically create DNS that you need for different environments. And then there's a bunch of other sort of additional controllers you can use. We've written our own to sort of handle health checks. The advantage of having this in your cluster is sort of comes back to the separation between the infrastructure layer and the application layer. So if you're configuring something like cert manager or external DNS sort of in your infrastructure layer, and then through annotations or CRDs or whatever the system uses to like sort of take advantage of it, your application developers don't need to worry about the lower part, and they can sort of use this. Why this matters is that most of these tools assume a single cluster. So if you've got your system set up with your primary DNS pointing at this one ingress in your cluster, you're going to be needing to do some DNS fiddling as you migrate. So if you've got it set up like this, you can just disable external DNS in that one cluster and turn it on in the other one, or probably do it by hand to move things over. So just hand define your pool for round robin DNS as you move things over. So decoupling from the cloud. This is sort of a big part, right? Is try as hard as you might, there's always going to be some amount of application code that is using specific sort of APIs from your cloud provider. So things like object storage, like S3, or some kind of message passing or queues, or a machine learning workflow. And so there's not too much you can really do about that, right? Not yet. In the same way that Kubernetes has sort of democratized deployments, and Envoy and to some degree Istio is sort of doing the same for the networking layer. Hopefully someday we'll see Knative and Kubeflow or something similar in a place where you can have a managed version from a cloud provider. So, which is important for us, is not having to worry about managing it, but also being able to rely on this API across providers. So it really comes down to, as you're migrating your code, making the choice between having some standard, well-supported API across services, or relying on a managed service. We lean towards managed service, and that means rewriting portions of the application code. So we're doing object storage in S3. It means that we have to rewrite that to handle other object storage locations. So what to migrate when? Sort of deciding what you're going to do first. And you want to start with the things that are sort of not as important to your business and are dependent on and have fewer dependencies on the rest of your services. This is a good way to start sort of testing out your migration to a different provider. Does your cluster actually work? Is there some API that you thought you weren't using in this service, but you are? But it's also a great place to finish, right? So sort of, if it's not important, leave it to the end. So you end up with this sort of curve of migration. But the thing that sort of has been hard to accept for me is that you don't really have to migrate everything. Again, if the point is to make it, if we're looking to save time, or money as well, and the point is not just to use Kubernetes, then we can leave some workloads in the old cloud, or we can run them elsewhere. So we have a CDN set up, for serving image assets, and that's probably just going to stay running off S3 for a long time. So while you're doing this migration, though, you may either be able to talk sort of through the internet between clusters, or you may need to set up set up a tunnel between the two clusters. So this talk looks like it should be pretty good about setting up the a tunnel between two clusters. Fortunately, we are able to do over the public, sort of over the internet, so hasn't been too bad there for us. So we're actually coming to the end, but I do need to talk about the elephant in the room, which is data and state and Postgres for us, right? This is sort of the big thing about moving between any cloud service, is what do you do with your data? So we use a cloud provider managed Postgres, and that means that we're limited in the options that we have for actually replicating the data from one place to the other. Some of that limitation may come from the host of your current managed provider. Some of it may be where you're moving to. For us, I believe it's where we're going versus where we are. But again, this is a great place to look, to engage with professional services. This is sort of the same story that we've been telling for a long time for migrating data. And as much as you might not to, as much as you might not want to, maybe you can tolerate some downtime here. So doing a dump and then a restore, rather than worrying about sort of like a hot backup. And of course, it depends on your data. But there's a lot of other state and data that you'll have in your applications. So if we look at what we're running, you find these sort of places where there's tiny data. There's services that set up semi-persistent like caching for other services, or one service that is writing data for another service to read. And there's a few things that you can use Kubernetes for to help with this. So the first thing is shared ephemeral volumes in pods. You may have two separate services running where one is writing this cache for the other one. Like if you're just for serving like a website and you're periodically refreshing it, you could then, instead, you could convert those to being running in the same pod. And it really doesn't matter if you lose that storage or not, because you just rebuild the cache. The other tip is to try mounted config maps. Excuse me. So in this case, like we have a system that is writing data for another service to consume. So it's always unidirectional like that. And before we were doing this as a writing to disk and then reading from disk in the separate service. But changing that first service to actually rely on config maps and speak to the Kubernetes API, then let us sort of modify that first service that's writing the data, and the other service is able to stay the same and still read it from disk and just sort of periodically refresh. And Kubernetes will take care of any time we change the config map. It'll actually refresh the data in the volume for that other service. But if you have your state, your big database in your cluster, this talk is going to bring up federated and stretch volumes to sort of migrate across cloud providers. And that could be pretty crazy. So almost done here, but I did want to give a preview first for a talk from my coworker, Yelmer, who will be speaking tomorrow on deploying rock-solid applications with Kubernetes. So if you want to learn about making sure that your pods are actually running on different nodes when you want them to be, or setting up network policies, you can check out his talk. Okay, so that's all for today. Thank you for listening.